Hello, my name is Nick. I've been working on an Arduino project to basically stop the birds from landing in the trees around my front driveway. They've been pooping on my car, which is really irritating. So what I did is I built a device that has some sound files in it that play basically distress calls and other like birds of prey for the birds in my area. Anyhow, I'm going to walk you through the process that I've gone through in setting this up, and maybe you can learn something from it or make one of your own so that you can keep the birds out of your own front yard. I'm using an Arduino Nano compatible microcontroller here, and I have an old toy that one of my kids had, so I'm just using a speaker on it. And this is being powered right now just through my USB port on my Mac. So I'll show you what I've been working on so far, and then some of the changes I'll be making as I start to build the speaker. And I'm just using an old speaker that I had from one of my old computers. It has a 12-volt input, and we're going to use that to power the microcontroller, but I'll get to that a little bit later. For now, it's running, and I'll show you what I have, and then later on I'll show you again when it's all put together. So first I'll just show you the breadboard and the way everything's wired up, and then I'll move over to the software. As you can see, right here we've got a 5-volt coming out of here, and we've got a ground, also our TXD and RXDs. So the power on the breadboard obviously goes to the plus, and then the ground goes to the minus. You can see right over here the TXD and the RXD on the microcontroller. Main thing to remember here is if it's the TXD on this side, then it is the RXD over here, and then vice versa for the other cable, because one's transmitting and one's receiving. And that's just the way that you load the program onto your card itself. With the Nano and also the Pro Mini, since it's only got the one chip on there, when you're actually programming it, you have to push the reset button right before it loads, and I'll show you how to do that too. As a trick I had to learn early on, and I've gotten a little bit better since then. Anyhow, you can see right here we've got our power that's coming in, and I'm jumping it over to here, and I'm running it into the VIN port. When it's hooked up to the USB, you can actually put it on the 5-volt and it works fine. I put it on the VIN because that's the one that can take like 7 volts to 12 volts of power, and the speaker I'll be powering it off of is 12 volt. So just went ahead and hooked it up right here. Let's see, and then over here I have the ground. Let me see if I can get my view in here a little better. The ground's coming right into here to power the microcontroller, and then we're going to come down here. I have the sound files all loaded on my SD card, and those are running through several more ports here. So we've got the 5-volt in right here, and then a CS, an MDSI, SCK, MISO, and a ground. The sound card I'm using here, well, not the sound, sorry, the sound card, the SD card reader I'm using here, these are mapped a little bit differently than what you might normally see, but there's a good reference on which plugins that these are actually supposed to go into. So in my case, the 5 volts already hooked up to the power. The CS goes over here to pin digital 10. You can see right there, it's the yellow one. The MOSI is the blue cable, and it's going over here to looks like digital 11. right here. Sorry, I have terrible lighting here. The SCK is the white cable, and it's coming over here to D13, which is right here on this side, right here. The MISO is the green cable, and it is coming over here to D12. So you can get in there a little better. Right there's D12. And then finally we have the ground, which hooks up to the negative side. I have the pin D9 hooked up to go to the speaker. So right now there's a jumper that's just coming straight over here, and then it's hooking up to the actual speaker wire right here, which traces back up to the speaker itself right here. The other side of the speaker is just going back into the ground, and you can actually hear it playing right now. It's been playing the whole time. Let's see, any wires I've missed? I guess the last part of this is a little extra that I threw on. I jumpered the power and the ground over to this side in these bars, and then what I have here is actually a photocell. And its purpose is to see if it is daytime or nighttime out, because the sound files I have actually are weighted, and it's got some random calls that happen too in the code, and I want to play more nighttime sounds, and less frequently too, at night, and I want to play more daytime sounds and a little bit more frequently during the day. So what this photocell is letting me do is just see, is it dark out or is it not dark out? And the way this little guy works is you hook them up to an analog line. So in this case, it's hooked up to A0. And then I also have a 10K resistor in here to basically balance out the signal that's coming off of here. And what it's going to do is it's going to give me a reading between 0 and 1023. And I'll use that in the code to say, hey, is it dark out? Play the night stuff. Is it not dark out? Play the day stuff. So that's all the hardware wiring I have here. I'll go ahead and show you on my speaker real quick, just its hardware components. Right here is the plug-in for it, and in this case it plugs in right here, and I'll also be using this is the input number 1 for the speaker, and that's where my speaker wires will actually connect. Later on, it'll just go right here and here. Alright, let's hop back over here. We're going to jump to the code, and I'll make sure I get this posted out there too, just so you guys can download it and get to it and do your own manipulations to it. I'm using the Simple SD Audio library. I found it online. It seems like it works pretty well. I've been happy with it. And then I also created a class called BurData, which just contains the sound files and some specs for them. Like I said earlier, the SD card is on pin number 10, and then the photocell is on the analog pin 0. I had to do some hard coding in here. I haven't been able to figure out quite how to read a file reliably from the SD card to parse it. It's just a CSV file, so I just hard coded a bunch of stuff for now. I'll make it smarter later on when I get more time. Anyhow, moving along. So I initialized the BurData data array, create some buffers for the actual audio file. I have a function to see how much free RAM is on the device, because this guy, it's pretty small since it's just a nano, but using the SD card to offload the sound files seems like it works pretty well, so pretty happy with it. There's a reset function, and this guy is basically the equivalent of pushing the reset button, except it's done through the software. Alright, and then we'll step into our setup. So We're just writing to the serial output on port 9600, which you can see over here, just the output as it runs through. We come in here, we're going to start off and just say how much RAM do we have available. I noticed some really dissatisfactory results whenever it exceeded the RAM on the device, so make sure when you're writing your code you keep it below the footprint. And then we'll initialize the simple, what is it called? Simple DB audio. It's called SD Play when we're using it. But we're going to go ahead and give it initialization of the buffer. Write up some text. We're also going to set the pin. So here we're saying that it's on pin 10. Here's some additional settings to initialize that library with the different modes that you want. If it fails, what I do is I tell it to basically reset every 10 seconds to see if the SD card is in a better initialized state. So it's just some error handling, really. So if I was to disconnect the SD card right now, it would automatically reset itself when I plugged it back in. If everything's working like it's supposed to, then it tells you if the wiring is correct and the card is present, which is always nice. We're seeding all of our random calls just by doing a random read off of the analog 1 pin. So after that, we load our sounds. And I'll jump down to that function. So the sound files I have are just 1, 2, 3, 4, 5, 6, all the way through 11. I had a couple problems with some of my sound files, like 4 and 9. I couldn't get them to work. I'll show you how to generate those in just a moment. Those were challenging. I built them and then they didn't work, and I had to kind of keep digging and doing some more reading until I finally figured out how to make them the correct way. Either that or else it was a bad library that I had imported earlier on. So not really sure which one it was, but it worked now. So now we come in here, we load up all these files. Like I said, it was a CSV file I was trying to read earlier. So what we're doing is we're taking that bird data. It's really just a POJO, or a plain old data object. So the first field is the file name. The second one is the chances of that file being played during the day. The third field is the chances of it being played during the night. The fourth one is the duration of the file in seconds. And the fourth one is the minimum number of times that we're going to play that file, like in a row. So if you have like a short file like this and 7 seconds long, I want to play it more times just to give it some extra length, and hopefully scare those types of birds that are around at that point in time by playing that number of times. And this is really the minimum number of times we're going to play it. We use a randomizer to say it's going to be at least this and up to at most a higher number. So anyhow, you can see all these are set up. That ends our function here. That also ends our setup function. So now we're going to jump into the loop call. We're going to say that it's currently day, and then we're going to read the photo cell. And like I said before, that photo cell, if it is, it'll be a reading between 0 and 1023. Over here you can actually see when it read it last, it said it was 457, and that's just based off of the lighting that I have in here. But it's reading it currently as day, because I'm basically saying if it's under 100, then consider it night. I also put in a little extra here to say if the pin was below 15, we're going to default it to day, because if that's the case, there's a chance that the photo cell actually failed, and we would rather it play the day sounds than the night sounds. So I just want to kind of put that in there for best case scenario. Alright, so now that we've done that, what we're going to do is we're going to play randomly one of our wave files. So let's go to that function. Okay, we come into here, and what we do is we're going to summarize all the weights of the files for that time of day. So we come into here and we loop through the data, and it's going to give us back just the weight for that time period, add them all up. So I didn't look at the math earlier, but this comes out to probably about 100. I just try to kind of keep them equal, so it'd be easier to do the math later on. But the idea is that you can put in like a random number of, or sorry, any number of files with the right data configurations, and it'll do the math for you. Anyhow, going back up to here, the maximum times that the file will run is going to be 16 plus the minimum number of times. So we can see that right here. So if we said it's going to play at least 4 times, then we're going to say it's going to play between 4 and 20 times. And then when it plays that file, it's going to randomize that, just to randomly pick a number between there. And that'll be in the play sound function that we have. What this basically does is it kind of keeps looping up until it finds a file to play. I'll let you just kind of dig into the code itself. When I came across it, I was pretty happy with the way that it worked, because it's basically taking all of your files and distributing them across a range, and whenever this adds up to a certain number, it's basically giving you an equal chance, well, sorry, a weighted chance that random number will find the file to play. So anyhow, just read through it. You should be able to understand it. It's not too complicated. So like I said, after it gets to this point, we're going to play the sound file. We pass some of our data into it. So here's our file name itself. Here's how long it's going to play, and here's how many times we're actually going to execute it. And then we spit out to the serial monitor how many times we're going to play it, just for so we can see what's happening here. So like here I'm saying it's going to play the 8.wave file 17 times, and the duration of that file is 15 seconds. So it comes into here, loads the file right here, and then it plays the file, and then while it's playing that, what we're doing is we're putting a delay in, because it's going to spin the actual playing of the file off into its own thread, and we don't want to keep executing code while it's doing its thing, because we can cause interrupts to happen while it's playing, and that's not really desirable, especially since we want to keep looping over this. What I do is I also go ahead and call the stop function in the library, just to make sure that that file gets unloaded as much as possible. I'm also going to look and see if there were any errors that happened. So in this case, if it's in the middle of playing, and then, like I said, the SD card gets ejected or fails for whatever reason, what's going to happen is it's going to go into an error state. It'll spit out the error code, and then it's going to reset the microcontroller again. So it's going to sit here, and it's going to keep on looping around over and over for the number of times that we told it to play. And then at the end, it's going to kick out and just say how much RAM is still free. The idea there is, if we needed to, we could say, hey, the RAM's getting really low, and we can reset the microcontroller again. It's not coded in, because I haven't really collected enough data on that yet, but the possibility is there. Alright, so that's all the code. Like I said, I'll kind of throw it up on the web somewhere and make it public for you guys to get to. But that's the first part, and once I get everything soldered together and working on the main speaker, I'll jump back in one more time and kind of show you. The nice thing about the speaker is it has amplification on it and everything. It's also got volume control and tone, so I can boost up the sound. The place where I'm going to be putting it is actually up in my attic, right by an air vent. That way I can still see enough light to cause the photosensor to act properly, but the tree that the birds are landing in is right in front of the house, so it's actually a good dry place to keep it, and it'll keep all the birds out of that front air vent anyway, because we've built a couple nests in the past. Anyhow, I'll see you soon. Okay, I'm back. I finished soldering all the different components together. I also used some tape just to kind of keep them separated out, since we've got some different voltages running through there, and when I'm putting the case back on here, I really don't want to accidentally short anything out. So a couple of key points to kind of show you. Right here you can Right here you can see the different solders. Make that clear. There you go. The power line came in right here, and the ground is going out here. The input is right here, so that's where we're going to send our digital pin 9 onto this board, and it actually maps to the same kind of input that we actually had on the speaker just normally. So basically what we've done, we've just hardwired in the sound, or the sounds on the wave file, so it doesn't need like the computer source or some other source to give it the signal that it needs. I'll go ahead and show you the schematics, because I changed them just a little bit since I was dealing with 12 volts instead of the 5 volts from the computer. So here you can see the way that this was wired up when it was hooked up to the computer. You can see right here that's the USB, and then these are all the different ports that came off of it. So that's where it was getting its power from. And changing over, we're using the wall wart, which is a 12 volt DC, which came off of 120 volt AC, and really just look through this diagram to see how things are rewired. Also, you'll notice like there's no TX or RX hooked up anymore because it's not being programmed. It's already got the final program on it. Otherwise, it has all the same other components as it did before. So I'll go ahead and show you this out, or show this to you guys. There you can hear it. And like I said before, this has some extra controls on here, so if I need to make the volume louder, I sure can. Seems like that one's just going to play 3 times. We'll see if another one comes up. There we go. I'm going to kind of tweak the tone here a little bit too, I guess. So there's that. Oh, and then on the front you can see the photo cell. So that will be used for the day and nighttime. How I made the wave files. So for that I actually used iTunes, and there's other programs out there to let you do it. But I had my files, and when they're on the SD card in the FAT format, it uses the 8.3 notation, so it can be 8 characters long with a dot and then 3 more characters, which is the file extension. I just named mine like 1, 2, 3 on up. It doesn't have to be exactly 8, it just has to be less than or equal to 8. So in iTunes, like I had my album, or just the file itself, and what you need to do is go under Preferences, and then under the General tab you'll go down to Import Settings, Normally it would be under MP3 because that's what iTunes, I believe, uses by default, unless I changed it at some point in time. What you want to do is change it over to the wave encoder. And by the way, if you wanted to make MP3 files for like an MP3 type project, you could do it through there as well. And then you're going to change your setting to custom. And what you want to do is take your sample rate and bring it down to 16 kilohertz. Your sample size is going to become 8-bit, and your channels is going to become mono. Probably right before you do this step, you want to take a note of what your existing settings are, because any files that you upload into iTunes will use this setting. So right now you just want to use it for generating your files, and then you want to change it back when you're done. So we'll say OK, say OK again, and one more time. And then in there you can either like choose your file this way and say create wave version, or if it's part of an album you can do the same thing just by clicking on this, opening the context menu, and then you go down to create wave version, and that'll create the file for you. And then it's just a matter of taking that file and putting it on your SD card so that you can play it. I'm going to jump back over to the code because there's another spot that I forgot to tell you about as well, and that was after the play random wave file. I have a randomized duration on here. So at the very beginning, remember I told you about during the day we play more frequently. So you can see here it's going to wait between 10 and 180 seconds before it plays the next set of files. And at night it's going to wait 75 seconds to 900 seconds. And obviously you can do the math to see how many minutes that is. And then after that we kind of roll into how long the actual wait time is. So that way we're not just constantly playing sounds all day long and all night long. We don't really want the birds to get used to hearing the sounds constantly. We kind of want to keep it somewhat random so that they never develop a pattern to it. Alright, I'm back again. I wanted to show you guys the final version. It's all put together. Looks like a regular computer speaker, with the exception of the little sensor. I'll go ahead and plug it in, let you guys hear it real quick. There you go. Works just as expected. I also had an opportunity to go grab another one of my nanos, and I was going to show you how to load the program on there, or load the sketch on there rather. So here we go. What you do is you go into your program and you say you're going to upload the sketch. You can see it's compiling on the bottom there, and you click it right there. So right when I said click, I hit the reset button on the Nano, that little guy right there. If I can get my camera to focus. There we go. So remember, that's just your reset button right there. I clicked on that right when I said click, and you got that output. If I don't click on it at the right time, what you'll see is an error that comes up. It's like here I say upload. Right there's where I should have clicked it, right before it started saying send, and it says it's not in sync, and it just fails out. So for anybody out there that's getting started and trying to figure out why they can't get their sketch to upload, they're using the Nano or the Pro Mini. That's why. Anyhow, I hope you've enjoyed kind of working along with me, going through this walkthrough and learning how I built the bird scaring speaker thing. Hopefully you guys can build one too and keep the birds out of your own yard. Alright, hope you enjoyed it.